Alright, in this section we're just going to cover how to simplify by rewriting using only sine and cosine. So, again, all you're going to do is when you're to simplify and it asks you to use only sine and cosine, all you have to do is convert all the trig function into sine and cosine using the reciprocal and the quotient identity. Now, there's some cases where you might use the Pythagorean identity to simplify even further. Now, in this example, we have tangent theta plus cosecant theta. There's something I want to add first. Even though it's using theta, you can rewrite it as x. So, tangent x plus cosecant x. So, when you see something like that, it just basically means tangent theta is the same thing as tangent x, cosecant theta is the same thing as cosecant x. Just different, different letters or different angles, different forms. But it still means the same thing. But I'm still going to work with this. Now, you can use this and the process still apply for both of them. It's just here we're using theta, over here we're just using x. They're both variables. Alright, so if I were to rewrite it, now this one, for tangent, I would use the quotient identity. So tangent theta is equal to sine theta over cosine theta. Then here I would use the reciprocal identity for cosecant. So cosecant, which is 1 over sine theta. Now, you notice how I included parentheses on tangent and cosecant, but not on sine and cosine? That's fine. It's okay as long as you have your theta there. You cannot just write sine over cosine. You need to write sine theta over cosine theta, or if it was tangent x, you would write it as sine x over cosine x. So it's okay to leave out the parenthesis. Sometimes I keep it for notation, but you can leave it without it, so this is fine. So I'm gonna rewrite it in this form. So tangent theta was sine theta over cosine theta, so I'm gonna write right here. Plus cosecant theta was 1 over sine theta, so I'm gonna write right here. Now, there are two fractions being added together, but you cannot add them because they have different denominators. So, it's similar to how to add fraction when you get common denominator. Well, when you're looking for a common denominator, you need to make them to be the same denominator, which is like you multiply top and bottom. So in this case, the only thing that we could do to find common denominator is if we were to multiply them to each other. So what I mean is, if I was to multiply the left side by sine top and bottom, and then if I were to multiply the right side by cosine top and bottom, so again, if I were to multiply on the left side, sine theta times sine theta will be sine squared theta over sine theta cosine theta. So we can write it like that. Plus 1 times cosine theta would be cosine theta over sine theta cosine theta. So now they have the same denominator, we can combine the two fractions. So as long as they have the same denominator, we can add the top. So we're going to write it as one fraction. On the top, it will be sine square theta plus cosine theta over sine theta cosine theta. So, and I'm looking if I can simplify, if I can factor out, which I cannot, because if I were to factor out, these two parts would have to have sine, or these two parts should have cosine in order to factor, which they don't. And I can't do anything on the bottom. So this is the part where I would stop and I would box that up. Now, there's a little note I want to add. What happened if, instead of it was sine, cosine on the bottom, what happened if it was, and I'm going to rewrite the answer, so sine square theta plus cosine theta over cosine theta sine theta. What happened if we have something like that? Well, then all I can say is it's okay. All I did was switch the factors on the denominator. So again, if I go back to here, when we were multiplying to get common denominator, it was sine theta times cosine theta, which became sine theta cosine theta. But it still means sine theta multiplying to cosine theta. So over here on the right side, cosine theta sine theta, it just simply means cosine theta times sine theta. So it's okay if it's in different order, as long as it's multiplying, that's fine. For example, if I were to go over, say, 4 times 3 versus 3 times 4, see how the numbers switch? It's the same thing with these trig function. Even though they're multiplying, they switch. If I were to relate it in terms of number, 4 times 3 is 12, and 3 times 4 is also 12, which is the same thing. So this is the same thing as the one we boxed. So sine squared theta plus cosine theta over sine theta over cosine theta is the same thing as sine squared theta plus cosine theta over cosine theta plus sine theta. So it's okay if you switch the trig function on the denominator, as long as it's multiplying, it's okay. Plus and minus, it might be not that easy because of sign. You have to be very careful if it's positive or negative. You have to be very careful if you want to switch them. But when it's multiplying, it's okay. Alright, in this example, we have secant theta plus tangent theta over cosecant theta. So, what I'm going to do in order to convert into sine and cosine is I'm going to use the reciprocal for secant and cosecant, and I'm going to use the quotient identity for tangent. So if I were to rewrite it, for secant, it was going to, this reciprocal identity was 1 over cosine theta plus, because of that plus sign right there, the quotient identity for tangent is sine theta over cosine theta. Next, on the denominator cosecant theta, the reciprocal is 1 over sine theta. Alright, so looking at this, if I look at the numerator of the whole big fraction, I can add these two fractions because they both have cosine, which is good. So I'm going to write right here, 1 cosine theta plus sine theta over cosine theta will simply be, add in the numerator, so 1 plus sine theta over cosine theta over 1 over sine theta. So we have a fraction divided by another fraction. So just like in 4.3, we're just going to rewrite it as a division. So I'm going to write the numerator first. 1 plus sine theta over cosine theta. That's the numerator divided by now our denominator, which was 1 over sine theta. And when we're dividing with fraction, we can rewrite it as a multiplication. Keep the first one the same. 1 plus sine theta over cosine theta times, flip the second fraction, so sine theta over 1. So it's multiplying after we flip the second fraction. So let's multiply straight across. So 1 plus sine theta times sine theta. Let me write it out here. 1 plus sine theta times sine theta. So that's what happens here. Cosine theta times 1 is simply cosine theta. Now, here we can just simply distribute the sine. Oh, I put my theta right here. So we can distribute the sine theta into everything that's inside the parenthesis. So this will become sine theta times 1 would be sine theta plus sine theta times sine theta would be sine square theta over cosine theta. Now typically, when we have something like this, we put the ones with the highest exponents first. So sine square theta plus sine theta over cosine theta. Now, I did this because sometimes there's two forms of answers. Now, you can have this or this. I wrote both of them just in case, because maybe your professors on your college exams, they might want you to leave it like this on the left, right here. Or they might want you to distribute the sine theta to everything inside the parenthesis, which you will get sine squared theta plus sine theta over cosine theta. For me, it doesn't matter because they're both the same. Now, again, I show you both these answers based on your professors when you take higher math or pre-cal or college algebra. When you're setting up simplifying, they might have a preference on how the answer should look like. For me, it doesn't matter because these two are the same. The one on the right is just simply after you distribute the sine theta to 1 plus sine theta. To me, it's the same. So if you give me the left one, that's fine. If you give me the right one, that's still fine. You still get full credit. But I'm just showing this to you just in case when you take your college math classes, your professor might have a preference on how the answer should be or how the answer should look like. But if you choose to distribute sine theta, that's fine as long as it's done correctly, and I will accept that. If you don't, then that's okay. You can leave it like this. But if you are able, for both parts, if you're able to simplify, then you do have to simplify. So always check if you can simplify, such on a quiz or on a test. Always check if you can simplify. Alright, in this example, we have cosecant theta times secant theta, and then minus tangent theta. Alright, so what I'm going to do when I'm converting to sine and cosine, I'm going to use the reciprocal for cosecant and secant, and I'm going to use the quotient for tangent. So the reciprocal for cosecant is 1 over sine theta and then for secant, now keep in mind it's multiplying, so I'm going to write multiply. The reciprocal is 1 over cosine theta. And then there's that minus. The quotient for tangent is sine theta over cosine theta. Alright. So when I'm simplifying, 1 over sine theta times 1 over cosine theta will be simply just 1 over sine theta cosine theta. That's all it is. Minus sine theta over cosine theta. Now, if we were to combine these two fractions, they don't have the same denominator, but as you can see, they both have cosine theta. The only thing that's missing on the right side, the right fraction, is sine theta. So what I'm going to do is I'm going to multiply the right fraction, top and bottom, by sine theta. So if I do that, the left fraction will stay the same. So 1 over sine theta cosine theta minus, and I'm going to multiply the right fraction top and bottom by sine theta. So on the numerator, sine theta times sine theta will be sine square theta over cosine theta times sine theta is the same thing as sine theta cosine theta. So I'm going to write it in that form. So sine theta cosine theta. So now they have the same denominator, I can combine the numerators. So 1 minus sine squared theta. So I'm going to write it as one fraction. So 1 minus sine square theta over sine theta cosine theta. Now here we're not finished. The reason we're not finished is because I notice we have a sine squared theta and we have a 1. That's almost identical to the Pythagorean identity. So if we go back to the Pythagorean identity, which was sine square theta plus cosine square theta equal to 1. Now, is there a way I can get this identity similar to 1 minus sine squared theta? Yes, there is. If I was to subtract both sides by sine square theta, so the sine squared theta cancels out, and all that I have is cosine squared on the left side, cosine squared theta. So cosine squared theta will equal to 1 minus sine squared theta will simply be 1 minus sine squared theta. So I'm using the Pythagorean identity, rewrote it as cosine squared theta equal to 1 minus sine squared theta, which is identical to this. So that means I can switch it out with cosine squared theta. So I'm going to write over here, instead of 1 minus sine squared theta, I'm going to put cosine squared theta as the numerator. So cosine squared theta over my denominator, which is sine theta and cosine theta. Now here, I'm not finished. Let me rewrite cosine squared theta as just simply cosine theta times cosine theta over sine theta times cosine theta. So as I rewrote cosine squared theta as cosine theta times cosine theta, I notice that there's a cosine theta in the numerator and there's a cosine theta in the denominator. So I can divide, which becomes 1, and the only thing I have left in the numerator is 1 cosine, and in the denominator I have just 1 sine. So on the top and on the bottom, I divide 1 cosine theta, and I'm left with just cosine theta on the top and just sine theta on the bottom. Now here, you can actually convert it using the quotient identity. The quotient identity for cosine theta over sine theta is cotangent theta. So that would be our final answer because there's nothing you can simplify. And here, if you have cosine theta over sine theta, where you can convert it using either the quotient identity, the reciprocal identity, or the Pythagorean identity, then do so. Here, we use the quotient identity. Cosine theta over sine theta is the same as cotangent theta. So the answer to cosecant theta times secant theta minus tangent theta is cotangent theta. So it's a long process as long as you do it correctly. I highly suggest this to do it slowly, don't rush it. So always convert into sine cosine. Make sure to be able to combine fraction with common denominator, and always check if you can have or use Pythagorean identity. I check because there's a 1 and there's a sine squared theta, and here is the Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. I rewrote it where it's cosine squared theta equals 1 minus sine squared theta, which is identical to this. So I switch out 1 minus sine squared theta with cosine squared theta and wrote over here. Continue to simplify and got it down to cosine theta over sine theta. Using the quotient identity, our final answer is cotangent theta.